Hi, Rajan Desai. Welcome to the channel. Today we will discuss sixth problem of our 100 question DSA series. And the problem which we are going to discuss today is the minimum platform required for a railway station. So the problem statement says you will be given arrival time and departure time of multiple trains, and both arrival and departure happens on the same day. And we have to find out the minimum number of platforms needed so that no trains wait. And a platform cannot serve two trains at the same time. So at the same time, let's say you have two trains, right? So you would be having two different platform for that. And alternatively, we can also say if a train arrives before another departs, one extra platform is required, right? Both statements are exactly the same. So let's try to understand through one example. So let's say I have four trains and these are the arrival time and the departure time. So first what we will do, we will uh, let let's try to locate them in a number line. So this is the time number line where all the times would be located in increasing order. So the minimum time here is 12:51, right? After that, the next time is 2:19, 2:19. Then the next time is 2:55. Then the next time is 3:55. Then 4:49, 4:49. After that, 6:33. Then 9:54, 9:54, and then 10:49, 10:49, right? So these are the timelines, and let's see in between which timeline which train you have. So from 2:19 to 9:54, 2:19 to 9:54 you have T1. This is T1. This is T1. From 2:55 to 3:55 you have T2. This is T2. From 0051 to 10:49. Okay, the maximum duration. This is T3. And the last one T4 from 4:49 to 6:33. So in between this timeline you have T4. So in this problem, we had to find out what is the minimum number of platforms needed so that no trains wait, right? If you think about it, this statement, I mean, finding minimum number of platforms so that no trains wait, which is exactly equals to finding maximum number of trains at any particular time. This statement is exactly same as this one. Like we know that we have to find out the minimum number of platforms so that no trains wait, right? If no trains wait, what it means, let's consider this timeline for example, right? So in this timeline, how many trains you are having? You are having T3, T1 and T2, and all three has to stay on a like on a platform, right? So if these three stays on a platform, and we know that a platform cannot serve two trains at the same time, what it means, it means that for these three trains you must have at least, like you must have at least three platforms. So here in this test case the answer is 3, because at any particular time what is the maximum number of trains which you are seeing, which is 3, right? From timeline this to this, I mean from 2:55 to 3:55 you are having 3 trains, and from 4:49 to 6:33 you are again having 3 trains. So for 3 trains you would need at least 3 number of platforms to let them stay, right? Let's like I would like to add one extra train here. Let's say I add one extra train, T5. Let's say the time is 4:49, but the end time is 9:54. Let's say 9:54 T5. So it would be present from 4:49 to 9:54, right? Now think about it. This is my T5. Now think about it. What is the minimum number of platforms now you would be having so that no trains wait, which is 4, because at like in between time 4:49 to 6:33 again you are having 4 trains, and for 4 trains you must have at least 4 platforms to let all 4 stays um, like without any problem, because we know that one platform cannot stays like cannot serve two trains at the same time. So here the answer for this test case is 4. So yeah, I hope you understand this problem, like what is this problem exactly. So now our objective is to find out what is the maximum number of trains at any particular time, right? So just a quick thing which I would like to highlight, that whenever in a problem you are given some start time, in time, arrival time, departure time, always try to see if sorting helps. If you somehow sort this data by either arrival time or departure time, if it helps, because I'm 99% sure in these kind of problems, right, arrival time, departure time, the start time or in time, or some range problem left and right, always try to see if sorting helps, right? So to solve this problem, what we will do, we will first sort all these arrival time, departure time combination based on the arrival time. So we will sort the all the train data based on the arrival time. So if you sort this, you would be having 0051, and then 1049, then the next would be 219, 219 comma 954. The third would be 255 comma 355. The fourth data would be 449 to 633. See, for T4 and T5 the arrival time is same, but if you do a sorting, then if the arrival time is same, then the sorting would be happening based on the departure time. So that's why 633 comes first, and then you are having 954, right? So now we have to find out what is the maximum number of trains at any particular time, right? So in this test case, if you see, let's say I'm at any general index I, right? At any index I want to see how many trains have arrived so far. There are three trains, right? So if you sort them, and if you just do a for loop for int I equals to 0 to I less than uh, so whatever number of trains is I plus plus. So if you are at index I, then how many trains have arrived so far? I plus 1, right? So let's consider I start from 0. It's a 0 base index. So 0, 1, 2, 3, and 4. So at any particular time, how many trains have arrived? I plus 1, right? We know that at this particular time, I mean, like at this ith index, how many trains have arrived? 3. Like for example, let's say I is equal to 2. So till here, 3 trains have arrived, 1, 2, and 3. Now, if you somehow find how many trains have departed, let's say that number is x, then what is the train that is present at this particular time, like on the platform, which is I plus 1 minus x. That's it. So in between this range, I know that 3 trains have arrived, and let's try to find a way, like we'll discuss it later, how to find how many trains have departed so far. If you somehow know x number of trains have departed, so total arrival of train is I plus 1, and total departure of trains is x. So then I plus 1 minus x is the train that is present on a platform at, like, in between this range, right? So I hope you understand this. So now our problem has been reduced to find out how many trains have departed by the time I present on the platform. So what we can do to solve that, we know that the arrival time of I is 255, right? So if you somehow find out how many how many departure times are there, that is less than my arrival time. What it means? My arrival, like, so this ith train would come at 255. If you somehow find how many trains are there, how many trains were there, that whose departure time is less than my arrival time, what it means? It means that those trains have already departed. I hope you understand. The total trains that has arrived at index I is I plus 1. The total departed is x, and how to calculate this x? We can try to find out how many trains departure time is less than my arrival time. Those trains are already departed, so that is the value of x, and we can easily find out how many trains that are present on a platform, right? So in this example, if you see, uh, if i if I show you at T5, let's say, so we know that the arrival time was 449, and the departure time was 954, right? So by the time here you had 1 2 3 4 5 trains have arrived, 5 trains were arrived, minus, let's see how many of them have departed. So the arrival time of this is 4:49. Let's see how many trains were there whose departure time is less than this. 10:49 is more, 9:45, 9:54 is more, 3 c 3:55. This this was this train was T3, this train was T1, this was T2, this was T4, and the last one was T5. See, the arrival time of T5 is 4:49, and by the time only T2 has departed, because its departure time is more is less than my arrival time. See, like we can also see this number line, from this number line. See, T2 is the only train that has departed before T4 arrives. What it means? It means that by the time T4 would present, you would be having 4 number of trains available on the platform, because 5 have arrived minus departed is just 1, so 4. We can also see at T4 there are 4 number of trains, right? So I hope you understand this. So now let's see how to find a exact algorithm to solve this problem. We will try to understand the algorithm now. So we are given an array of arrival and departure time, right? So first what we will do, we will keep a pair of arrival time and departure time of all these n number of trains into some vector, right? Let's say I stored it A3, D3. So these are arrival and departure time. Then you sort it, as I mentioned in the explanation part itself. Sorting will always help you. So first sort it, and then let's say these are your arrival and departure time vector after sorting, right? So what we will do, we will go through each of the index I. So by the time I come, how many trains have arrived? I plus 1, right? I plus 1. So considering it's a 0 base index. Now what we can do, we can find out how many trains are there before I whose departure time DJ is departure time is less than my arrival time. We can just keep on like incrementing a variable. Let's say I initialize with x is equal to 0. And what we will do, so whenever you see a train whose departure time is less than my arrival time, just do kx plus plus, right? And after that, then how many trains would be there at this particular time, current time? Total arrived train I plus 1 minus total departed train. This is x. So these many number of trains are present at this particular time. So if these many number of trains present, it means that you would be having at least these many number of platforms, right? So let's say you have a answer variable. So what you do, you update your answer is equal to maximum of answer comma this I plus 1 minus x, right? So let's see how the pseudocode would look like. Let's say I have two variable, int answer is equal to 0 and my x is equal to 0. So x is the number of train that have departed so far. Now let's go through each of the train. So for int I equals to 0, I less than n, I plus plus. So what I want to find, I want to find how many trains were there before I whose departure time is less than my arrival time, because those trains have already departed, right, before I came. So let's say this is called a variable int x is equal to 0. Now you go through another for loop for int j equals to 0, j less than I before I, right? So for I want to find out how many trains were there before I, right? J less than I, j plus plus. Just check if my departure time, let's say departure time is dj, is less than my arrival time a of I. So the arrival time of ith train, if more than the departure time of the jth train and j is less than I, then do x plus plus. And after that, just update your answer. Answer is equal to max of answer comma answer comma total arrived train I plus 1 and total departed train x, and that's it. And at the end return your answer. Return answer. So yeah, this is the brute force approach of this problem. So here the complexity, as we can see, order of n square, right? Because we are using two for loops, right? So we are going through each of the train from I equals to 0, I less than I plus plus, and for each of the trains which is less than I, like before I'm just trying to find how many trains were there whose departure time is less than my arrival time, because if the departure time is less than my arrival time, it means that those trains have already departed. So just increment that x, and at the end return, just update your the maximum answer, right? Because I want to find out how many maximum number of trains that can have at the same time. So just update your answer, I plus 1 minus x, and because we know that I plus 1 is the total number of train arrived so far and x is the number of train departed so far, so just do I plus 1 minus x. So yeah, this is the brute force approach of this problem, but we can optimize it further, because we know that all the arrival times are in increasing order. So if you somehow keep track of this x, because here what you are doing essentially, we are calculating x number of departed time, each number of time is starting from fresh, right? For each I we are starting from j equals to 0, j less than I, j plus plus. We are doing this process again and again. To optimize it further, we can use some kind of BST, balanced search tree, or red black tree, red black binary search tree, right? Like you don't have to implement these binary searches in STL. That is easily available using set or multiset. So you can make use of this set and multiset in order to do this process like efficiently. The multiset could be used because here if you think the departure time could be duplicates also, right? So like then you have to use multiset, but the behind the scene implementation is done using binary search tree, right? So yeah, this is all about the brute force approach. Now let's look at the optimized approach using multiset. So using multiset, the complexity now reduced to order of n log n from order of n square. So yeah, we'll discuss what is the optimized version using multiset. Yeah, let's see now. This is the accepted code, and this code is written exactly how I've explained in the explanation part, so I would highly recommend to check out the explanation part first. So in this problem you will be given arrival time and departure time of n number of trains, right? So first find out how many trains are there. So you have n number of trains. Then as discussed in the explanation part, what we will be doing, we will be storing the information of arrival time and departure time, right? A pair of arrival time and departure time into some vector, and we will sort them, based on the increasing order of the arrival time. That's what I have done. I have kept a pair of arrival time and departure time of all the n trains into some vector. So this vector is called duration vector. Then I sorted this. Then I have used a multiset. So I will explain what this multiset does essentially. Now here this is my answer, the maximum train at the same time. As mentioned, since like though you have to find out how many minimum number of platforms required so that no trains wait, but we already know that this statement is exactly same as finding how many maximum number of trains that can have at the same time, right? So this is your answer, and at the end return this answer. Now x, as mentioned in the explanation part, x is the number of trains that have already departed so far, right? And so we will discuss x and leave time, this multiset. So now what we are doing essentially, we are going through I equals to 0, I less than and I plus plus. So after sorting, let's say this is your pair of arrival and departure time, A3, D3 and A4, D4 and so on, right? Let's say I'm at any particular index I. So my arrival time is this duration dot I dot first, since this is a pair, so you can face the arrival time and departure time by taking I dot first and I dot second. So my arrival time is duration I dot first, and my departure time is my duration I dot second. And one more thing, this multiset essentially stored all the departure times. So by the time you come to I, your multiset would be having D1 and D2, right? So what I'm doing here, I'm kind of removing all those departure time which is less than my arrival time. Let's say I is equal to 3. So remove all the departure time from the multiset whose value is less than my arrival time, because these trains have already departed, right? So if your arrival time is less than my arrival time, what it means? It means that you have already gone before I came, right? That's why just remove all these departure time from this multiset. That's essentially what I am doing here. So while this multiset is not empty, and one thing why I have used multiset is because this departure time could be duplicate also, right? uh, so it's possible that two trains depart at the same time. So since we want all the numbers to be have in increasing order as well as to handle the duplicates value, that's why I've used multiset here, right? So let's say in the problem, if it is says that all the departure time are unique, then you can use set also, it's okay, right? Then what I'm doing here, while this multiset is not empty and while its first value is less than my current arrival time, just keep on removing these. So it will essentially remove all the departure time which is less than my arrival time. And each time, so whenever you depart, just increment x plus plus, because x is the number of trains that have already departed so far, right? So whenever your train departs, just do x plus plus, because now one more train had departed by the time ith train arrives, right? So this is x plus plus. Now as discussed, by the time your I come, how many trains have arrived so far? I plus 1, right? Let's say I is the 0 base index, so 0 1 2. We can see here 3 number of trains have come, and we already know how many trains have departed, x, right? So these many number of trains is actually present at this particular time, at current time. So essentially this what this variable is, total trains at current time, which is I plus 1 minus x, right? So once you know how many trains are there at this current time, then just update your answer. So your max train at the same time equals to maximum of this comma total train at the current time, right? And after that, just insert this current departure time into the multiset, because we know that the multiset contains all the departure time. So just insert it into the multiset, and that's it. And at the end, return your answer. So the complexity for this problem is order of nlogn, because we are going through all the n number of arrival and departure time pair, right? I equals to I less than I plus plus. Now at each time we are kind of removing the departure time from the multiset. And you might think that since this is a while loop, then how the complexity is order of log n. The thing is, if you observe it carefully, you would find that in the multiset we would be popping departure time at most one number of times. Either we remove or we don't remove. So once the once a departure time is removed from the multiset, we won't be keeping it again. That's why, since the pop operation is at most one, the overall complexity for this algorithm is order of n log n. Because in the multiset, your insertion and deletion takes order of log n, right? And each departure time can be pushed or popped at most one. So that's why the complexity is order of log n for push and pop, and the overall complexity order of n log n. And yeah, so that's all about this explanation about this problem, minimum platform required for a railway station. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching.